Hey guys, so like I said, I am going to be doing some Lewis structures with you. So we're going to walk through a couple of different Lewis structures. Some are going to have double bonds, some are not. And what I'm going to focus on is a couple of our polyatomic ions, not all of them, just some of them. Okay, so the first thing I'm going to draw is I'm going to draw, not with that. I thought, there we go. I'm going to draw ammonium. So as we know, ammonium is NH4 plus. So we have our So first things first, we have to figure out what is going to be our central atom. Our only choice is nitrogen because we have 4 hydrogens and hydrogen can never be our central atom. Our next step is we are going to count up our electrons. We have 5 electrons from our nitrogen. We have 4 hydrogens, so that is going to give us 4. This has a positive charge, which means you have 1 less electron. So anytime you have a positive charge, it means you take 1 away, okay? So it's going to be 5 plus 4 minus 1. This is going to give us 8. We have 8 electrons total. This one is a pretty straightforward Lewis structure. You have nitrogen in the middle, and you have 4 hydrogens. So we're going to do 1, 2, 3, 4. And we're done. So this is ammonium. The reason why we have a +1 charge here is because if we look at nitrogen, it has 1 more bond than it wants to. We know nitrogen's Lewis dot structure is 5. So 1, 2, 3, 4, 5. And we know that it has 3 available spots for bonding. 1, 2, 3. So anytime we see an ion that has a positive charge, it means that one of our atoms is unsatisfied. It's working a little too hard. So with our ammonium, nitrogen prefers to have 3 bonds, but right now we have 4 bonds. So this extra bond is going to give us that positive charge. Okay, so the next one that I'm going to do is going to be another polyatomic ion. I'm going to do carbonate. We're not going to do all of the polyatomic ions today, just because some of them have expanded octets, and that's what we're going to be learning when we get back from break. You're not going to be doing that. Okay, so I'm going to do carbonate, not in red. So as we know, carbonate is CO3, 2 minus. When we're counting up the electrons, anytime you see a -2, that means that we have a negative charge, so we have more electrons. So this actually means we're going to have 2 more electrons than we would anticipate, okay? So we have carbon. Carbon's going to give us 4. Then we have 3 oxygens, which is going to be 18. And then we have +2. So this is going to give us 24 electrons total. Carbon is always going to be our central atom because carbon is the center of attention. So we have carbon here. All right, and now we're going to put on our electrons, okay? We know that carbon is going to prefer 4 bonds, so we can go ahead and do that. What is up on that line? There we go. All right, so now let us fill in our lone pairs. So this oxygen only needs 2 valence electrons. Sorry, 2 lone pairs. It doesn't need 2 valence electrons. It needs 2 lone pairs. And we're good. So let's count this up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, we have the correct number of valence electrons. So now let's look at each individual atom. I'm just going to circle them so we can look at each one. Let's make carbon green. And if this helps you, it helps you. If you don't want to do this, that's fine. So our oxygen with a double bond, we have 2 pairs of electrons being shared, so that's 4. 2, 4, 6, 8. Our oxygen is all set. 2, 4, 6, 8. this oxygen is all set. 2, 4, 6, 8. This oxygen is all set. 2, 4, 6, 8. And our carbon is all set. Okay, so if you want to double check your work, you can count each individual atom because remember, 8 is great. They all want 8 atoms. No, they want 8 electrons. So they all want 8 electrons. They all have 8 electrons, and we have 24 total. The reason we have a -2 charge here is because we have 2 unsatisfied oxygens. So I'm just going to erase my circles real quick. So if we're looking at our oxygens, oh no, there we go. If we are looking at our oxygens, what we are going to see is that one of our oxygens has a double bond. So this oxygen is satisfied because it wants to make 2 bonds. Our carbon is satisfied because it wants to make 4 bonds, but we have 2 oxygens here that don't have that double bond. They don't have the number of bonds that they want, so -2. This one is going to be -1. This one's going to be -1. So that is why we have a charge there. You might be wondering, can I put this double bond on any of them? Yep, you can. So if you wanted to, you could put this double bond on your right-hand oxygen. You could also put this double bond on your bottom oxygen. When we get back from break, we're going to talk about resonance structures. And what that just means is that there's multiple ways that you can make the atom. And since all of these oxygens should have the same electronegativity, they should all be able to take the double bond. Okay. Last one that I'm going to do is nitrate. All right, so we know that nitrate has a charge of -1, and we have 5 valence electrons from our nitrogen. We have 18 from our O3, and then we have +1. All right, so we're going to have 24 here too. Yeah, I can do math. It's going to be 24. Good. Okay, so we're going to have nitrogen in the center, and then we're going to have 3 oxygens. All right, and we just saw a Lewis structure with 24 valence electrons where we had 1 central atom and 3 atoms bonded to it. So we know that there has to be a double bond because if we didn't have a double bond, we would have too many electrons. So if this is what we had, we would have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. We have too many. We know we need a double bond. So we're going to erase 1 lone pair from one of our oxygens. We're going to erase in a lone pair from, not in a lone pair from our central atom nitrogen. And we're going to double bond it. So this looks exactly like our carbonate atom. It is exactly like our carbonate atom, but you might be wondering why this has a -1 charge and the carbonate atom had a -2 charge. Well, the big difference here is nitrogen doesn't want to make 4 bonds. So we're going to have a +1 charge coming off of our nitrogen because nitrogen wants to make 4, it wants to make 3 bonds. And then we're going to have -1 here, -1 here. So now we have a -1 charge because +1 plus -2 is going to give us -1. And last one that I'm going to do is just I'm going to do some pretty straightforward ones. So I'm going to do CH4. I'm going to do C2H2. I'm going to do C2H4. And then I'm going to do C2H6. All right, so methane, first one. This is the chemical structure of methane, which you guys have heard about before. It is one of our hydrocarbons. It is used in combustion reactions. So if you, this burns in the presence of oxygen, but it needs a catalyst to get started, and that catalyst is always going to be fire. So this can cause explosions. All right, so we have 4 plus 4. We have 4 from our carbon, we have 4 from our hydrogen. So we have 8. That looks like a Y. So we're going to have H, 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 H. Okay, so that's our first one. C2H2, C2H4, and C2H6. This is really going to show us the importance of double and triple bonds. So when we're doing these out, we're going to see that bond length is directly related to bond strength. So length is strength. When you have something with a triple bond, so C2H2, you're going to have 2 carbons, so that's going to be 8 plus 2 gives you 10. We know that carbons want to make 4 bonds, so I'm just going to put the triple bond in the center. And remember that when we have hydrogens, it is the parent trap rule where they're going to split up whatever atoms they have because they both want to have an equal share. So if you have 2 hydrogens, then each is going to get 1. Then we have C2H4, so we have 2 more, so this is going to be 12. And then this one's going to be 14. So I'm going to do this one a little down so I have more room. And I'm just going to give each of them 2 hydrogens. Okay, and then our last one is C2H6. So we're going to have a single bond because they're each going to have 3 hydrogens on them. This was ambitious of me to try to do these all on the same page, but we're going to get it done. So let's do 1, 2, 3. If we were to have an open response and I were to ask you guys which compound, C2H2, C2H4, or C2H6 do you think has the strongest carbon-carbon bond? I would really love for you guys to remember that bond length equals bond strength. When you have a triple bond, you have 3 pairs of electrons being shared by 2 atoms. Think about the strength of those nuclei. The bond is going to be incredibly short every time you add another bond in. When you have a double bond, it's not going to be as strong, and a single bond is the weakest of the 3. So please remember that bond length is bond length is directly related to bond strength. Okay, I think that is everything that I wanted to put into this video. There will be a homework sent out just with some other double bond problems. If you guys have any questions, please let me know. And I hope that you guys have a great vacation. Where is my mouse?